Hello, and welcome to ICND1 Lab 7, IP Subnet Design and Implementation. For those of you following along with the Cisco Press exam certification guides, this video covers material that's also seen in the ICND1 books, Chapter 12. This video lab has three main objectives. The first objective is to show an example of how to identify the location of the subnets that are required for a particular network topology. The second objective is to help you become more familiar with the process of finding all subnets of a given IP network, in particular when using a single or static length subnet mask. Finally, the third objective is to review the process of how to find the range of IP addresses in each subnet. This video lab has three main scenario steps. In the first step, we'll examine the topology of a particular internetwork and identify both the number of required subnets and the location of each subnet. Then we'll take a single Class B network number and calculate all the possible subnet numbers when using the same mask throughout that network, and then identify the numerically smallest subnets. In the third scenario step, we'll actually pick IP addresses from each of those subnets to assign to the various hosts and routers in this internetwork. So let's begin scenario step 1 by taking a look at the topology used in the internetwork shown in this video. First of all, we've got a main site with a router, a switch, and a couple of hosts. Then we've got the first remote site with router 2, switch 2, and a single host C, and yet another remote site with router 3, switch 3, and a remote host D. Of course, to connect these two remote sites to the central site, we need some WAN links. So we'll put a point-to-point link between router 1 and router 2, as well as another point-to-point link between router 1 and router 3. Next, we'll use two rules to discover that we need 5 total subnets to support this topology. The first rule is that each LAN broadcast domain, or each VLAN if you prefer, should use a single subnet. So in this case, we have one broadcast domain supported by switch 1, a second broadcast domain supported by router 2 and switch 2, and a third one there off the switch connected to router R3. So each of those broadcast domains at layer 2 need a layer 3 subnet to support the IP hosts connected to those switches. Now if we take a look at the second rule, each point-to-point serial link also needs a subnet. So in this case we have two point-to-point links, so we'll need two additional subnets that you see here. Now before we move on to the next scenario step, let's consider a variation on this topology. So far I've assumed that each switch is supporting a single VLAN, most likely the default VLAN of VLAN 1. However, it could be that switch number 1 is supporting two VLANs in this particular case. Say for instance host A is in VLAN 2 and host B is in VLAN 3. To make that work, router 1 needs to support a feature called trunking, which then allows router 1 to forward packets between VLAN 2 and VLAN 3. Now because it's two different VLANs, that means two different broadcast domains. So up there off switch 1, we'd actually need two different subnets. So in real life, you're much more likely to bump into situations where switches have multiple VLANs. However, because this video lab is located with the ICND1 material, which for the most part ignores VLANs, we'll stick with the earlier case where each switch has a single VLAN connected to it. Next, let's take a look at scenario step 2, in which we will determine all the subnets of a particular Class B network and then choose 5 subnets to use for this topology. Now the network manager in this case has told us that we're going to use Class B network 172.20 with mask 255.255.255.0. The network manager has also told us that once we figure out what the subnet numbers are using that network number and that mask, that we want to use the smallest numeric subnet numbers to support the network that we're deploying. So a few things we can learn about that right away is, first of all, because it's a Class B network, we know there are 16 network bits, the whole first 2 octets. Then the mask tells us that the first 24 bits are the combined network and subnet field. Knowing that the first 16 bits are network bits, that means that there are 8 subnet bits. In other words, the whole third octet is the subnet part of the address structure. And then finally, the host part of the addresses will be the final 8 bits, or the entire 4th octet. Next, let's use the process described in ICND1 Lab 6 to find all the subnet numbers. Now, I'm not going to go through all the generic process here, so if you haven't watched Lab 6, it's probably good to go back and watch that first to get a better understanding here. But let's follow through that process just to see another example. First, we write down the subnet mask in the first row of this table. Then we put a box around the interesting octet. That's the octet that contains the entire subnet field in this case, which is all of the third octet. Then we calculate the magic number, which is always calculated as 256 minus the mask's value inside that rectangle. So we get 256 minus 255, or 1. So the magic number will be 1 in this case. Finally, to kickstart the process, we write down the network number again, because the 0 subnet number is always the exact same numeric value as the classful network number. Now let's continue with the process by adding the magic number to the previous subnet number to get the next subnet number. For instance, we just copy the 3 octets outside of the rectangle, and then we add 1 to this third octet, so 1 plus 0, of course, is 1. So our next subnet number would be 172.20.1.0. Now, from that bit of math, you can probably guess at the rest of the subnet numbers if you haven't already. We copy the 3 boring or outside the rectangle octets and add 1 to the third octet, which gives us 172.20.2.0. Adding 1 in the third octet again, 172.20.3.0, .4.0, .5.0, and so on and so forth, until we get to the final subnet, which is 172.20.255.0. Earlier in this lab, I showed how you needed 5 subnet numbers to support this particular internetwork, and that the network manager had dictated that you should use the 5 lowest numeric subnet numbers. So let's take a look at that with the network topology again. First, let's use a subnet up there on the top LAN, and in this case I've chosen to use 172.20.0.0, which is the 0 subnet. Now, following the LAN subnets around again, I chose to use the 1.0 subnet on the LAN on the bottom left, and the 2.0 subnet on the LAN on the bottom right. Now, of course, we need 2 more subnets for the 2 WAN links, so in this case I chose the 172.20.3.0 subnet for the left-hand serial link, and 172.20.4.0 for the right-hand serial link. Next, let's move on to scenario step 3. The network manager has made some more rules about what you should do with the subnet numbers now that you've chosen them. In particular, the manager says that you should assign the routers the highest IP addresses in their respective subnets, then assign the switches the next highest IP addresses, but then when assigning IP addresses for hosts, to use the lowest IP addresses in each subnet. Now, in order to pick those addresses, you need to find the range of addresses within a subnet, but to do that it's very helpful to first find each subnet's broadcast address. So that's what we'll do here at step 3. Now, earlier, IC&D1 Labs 4 and 5 showed you how to calculate the subnet number, broadcast address, and range of addresses in a single subnet. If you'd like to try to use that process again, it's a good time to pause the video and go try that out for these particular subnets. However, I'm going to show you a couple of variations on how you can find a subnet's broadcast address using the next subnet number, in case you might prefer to use that method. So first of all, if we want to find the broadcast address for the 0 subnet, which is 172.20.0.0, note that the next subnet is 172.20.1.0. Now I'm going to show you 2 methods. The first I kind of jokingly call the math-ish method because it's mostly like math, but I'm breaking a few rules here. So one thing we can count on is that the next subnet number is 1 larger than the previous subnet's broadcast address. So if I take subnet 172.20.1.0 and subtract 1 from the 4th octet, that should give me the broadcast address of the previous subnet. Now the problem, of course, is I can't subtract 1 from 0 there in that 4th octet and end up with a number that's a legal value to have inside an IP address. So we do like we do in decimal math, and we borrow. We borrow 256 from the 3rd octet and have a 1 lower value there in the 3rd octet. So we make this conversion to 172.20.0.256. This is why I call it math-ish as opposed to math. And then do the math and end up with the number 172.20.0.255, which is indeed the subnet broadcast address of the 0 subnet. So if you like this math-ish method, that's great. You've got a way to find subnet's broadcast address if you know the next subnet number. If you don't like that one, you could try this one. I call this the counting or intuitive method. You start with the previous subnet number and you just start writing down all the IP addresses in the subnet. For instance, here's the 0 subnet of 172.20.0.0, and the first IP address in the subnet is 172.20.0.1, and you keep adding 1 in the 4th octet. Now if you keep that up, you'll eventually get to 172.20.0.253, 0.254, 172.20.0.255, and then when you add 1 in the 4th octet again, you'd have 256. So instead of writing 256, which is out of range, you write down a 0 and carry a 1, and you end up with 172.20.1.0. Well, you might notice that's a bit different. In fact, that's the next subnet number. So knowing that fact, and knowing the fact that the previous subnet's broadcast address is 1 less than that subnet number, you can easily recognize that 172.20.0.255 is the previous subnet's broadcast address. Now, just to make sure this second version is clear, let's take a look at the next subnet, which is 172.20.1.0, and the subnet following that, which is 172.20.2.0. Now, to find the broadcast address for that first subnet of 172.20.1.0, we just start with that subnet number and count. So there's the subnet number. We add 1 to get the first IP address of 172.20.1.1. The next will be 1.2, 1.3, and you just keep going, and you get up to 172.20.1.253, .1.254, .1.255, and now when you try to add 1 in the 4th octet, you'd get 256. Well, you can't write that down. That's out of range. So you'd write down a 0 in the 4th octet and carry a 1, which gives you 172.20.2.0. Of course, that's the next subnet number. So the number prior to that is 1 less, 172.20.1.255, and that is the previous subnet's broadcast address. So now you've seen 3 methods of how to find a subnet's broadcast address. The method shown in labs 4 and 5, as well as the 2 methods shown in this video. Regardless of how you find it, once you know a subnet's subnet number and subnet broadcast address, you can easily find the range of valid addresses that can be assigned from that subnet number. In particular, the lowest assignable IP address is one larger than the subnet number, and the largest usable IP address is one smaller than the broadcast address. So the table that you see scrolling across the screen now simply shows the subnet number and broadcast address in each subnet, as well as the smallest and largest usable IP addresses in each subnet. Next, we'll complete this video lab by assigning IP addresses per the recommendation or suggestion of the network manager. Now remember, the network manager said the largest IP addresses in each subnet are assigned to routers, the next largest to switches, and then the hosts get the smallest IP addresses in each subnet. For instance, here we're going to assign the largest IP address of 172.20.0.254 to router R1's LAN interface, remembering that that's where we put the 0 subnet. The switch gets the next largest IP address of 172.20.0.253. Now the 2 hosts, A and B, need an IP address, but they get the smallest IP addresses in that subnet of 0.1 and 0.2, as you see there. Next, if you go down to the bottom left subnet, that's where we put the subnet 172.20.1.0. We've assigned router 2 the IP address of 1.254 and switch 2 the address of 1.253, the 2 largest IP addresses in that subnet. Host C gets the smallest IP address in the subnet of 172.20.1.1. Moving over to the right now, we've got the subnet on the far right, which is subnet 172.20.2.0. So we assign router 3 the IP address of 2.254, which is the largest IP address in that subnet, followed by 2.253 as switch 3's IP address. As usual, host D gets the smallest IP address in the subnet of 172.20.2.1. Continuing yet again, we move over to the left-hand side subnet, and now we've got 2 routers in this one subnet, so we need to use the 2 largest IP addresses in that subnet for the 2 routers. In this case, we'll assign router 1 the IP address of 172.20.3.254, and router 2 the IP address of 172.20.3.253. Finally, on the far right serial link, we'll need 2 IP addresses again in subnet 172.20.4.0 in this case. So we assign router 1 the IP address of 4.254 and router 3 the IP address of 4.253. This concludes ICND1 Lab 7. In this lab, you've seen how to identify the location of subnets that are required for a particular network topology. you've hopefully become more familiar with the process of finding all subnets of an IP network, in particular when using the same length mask throughout that network. And of course, we've reviewed the process of finding the range of IP addresses in each subnet.